All right, you guys. We got a ladder problem. Let's go. We love ladder problems. Okay. A ladder is leaning against the building. Oh, it's a 13-foot long ladder leaning against the building. So X is on level ground, Y is on the wall shown. X is moving away at a constant rate of 2 feet per second. Woo, this guy's flying. And Y is falling down. Find the rate at which the length of side OY is changing when X is 12 feet from the building. All right. First of all, let's look at our triangle for a second, okay? At the instant when X is 12 feet, this is a triple. All right, if you know your triples, it's going to help you go a little bit faster. This is 5 feet. Okay, so that's a 5, 12, 13 triangle. The next thing we're going to do is we're thinking about which sides are changing and which sides are constant. Now, as I'm flying out this way, right, X is changing. As I'm flying down the wall, Y is changing. But this side right here, the ladder is constant. Okay, so we just want to be kind of aware of that. All right. Perfect. Find the rate in feet per second at which the length of side OY is changing when X is 12 feet. I'm just going to call that dy dt. Okay. Part A. Okay, so we have x squared plus y squared is z squared. So I have 2x dx dt plus 2y dy dt. And remember that this side was constant. So when I take the derivative of dz, of z squared, I'm going to get 0. Okay? Now, side x is 12. Dx dt is positive 2. Side y is 5. I don't know dy dt, but it is going to be a negative number. It should when I get that. All right, so I have 12 times 2 times 2 is 24. That's 48 plus 10 dy dt is 0. If I subtract that over, 10 dy dt is negative 48. And then, so for my answer, divide by 10, I get, write it up here, dy dt is negative. You could put 48 over 10, or I'm just going to put 4.8 feet per second. Okay, so it's falling at a rate of negative 4.8 feet per second. Okay, part B. Find the rate of change in square feet per second of the area of the triangle. Well, I know an area of a triangle is 1/2 base times height. So I'll use x and y. I said part B and I wrote part A. Okay, so dA dt is, I'll go ahead and leave the 1/2 out front, and I'm going to do a product rule right here. The derivative of the first is dx dt times the second. And then the first, and then derivative is second is dy dt. Okay. All right. Dx dt is 2. Y is 5. X is 12. Dy dt is, negative 4.8. So that's 10 plus. I would let you use a calculator for that if we needed one. Negative 4.8. Okay. Negative 57.6. Let's see. Plus 10 divided by 2. So the area of the triangle is decreasing at a rate of 23.8 feet squared per second. Okay, negative 23.8 feet squared per second. Okay, now we're finding the rate of change of radians per second. All right, cool. So we need to come up with an equation. Now, you know, if all three sides are changing, it doesn't really matter if you use sine, cosine, or tangent. But in this case, I kind of want to incorporate that side because it's a constant. So I'm going to use sine. I'm also choosing sine because, I don't know, I think the derivative of sine is probably the easiest, right? So sine is opposite over hypotenuse, which is a constant. Okay, the derivative of sine is cosine theta d theta dt. The derivative of y over 13 is 1/13, because that's like a constant in front, okay? dy dt. Now, cosine theta, you just go back to your triangle and you go, okay, cosine is adjacent over hypotenuse, because now let's change the cosine. So it's 12 over 13. So adjacent over hypotenuse. And then dy dt is negative 4.8. Okay? To solve for d theta dt, I need to multiply both sides by 13 over 12, which will cancel that, and it'll cancel out those 13s. So basically, I get negative 4.8 over 12. And for response, you could leave your answer like that. I mean, if you're allowed to use a calculator, that's fine too. I know this divides evenly because 48 divides by 12. Yeah, evenly-ish. So I end up getting, we'll put it up here, d theta dt is negative 0.4 radians per second. So that angle is also getting smaller as this ladder is falling down. All right. That one was not too bad. A pretty typical kind of triangle question there. Okay, let's look at number 5. Okay, so here we go on number 5. I'm going to change part A. I just decided before I make copies of this. All right. Rectangle ABCD with sides parallel inscribed in a region enclosed by the graph of y equals negative 4x squared plus 4, and the x-axis is shown. Write the area of the rectangle in terms of x only. All right. So right now, the area of the rectangle, if I look, you guys, if this is a point, x comma y, that means from 0, 0, I go over x and I go up y, okay? But we know that the area of a rectangle is base times height, and the base is actually double that. There's 2 x's because it goes across 2 quadrants, right? So the area of this rectangle is actually 2x times y. But if I want to write it in terms of only x, I basically just need to change y into x. So how do I do that? I can actually do that with this equation right here. So the area is 2x, and then y is negative 4x squared plus 4. Now, you don't have to simplify that. I'm going to, because it's going to help me on my next step. So I'm going to go and write negative 8x to the third plus 8x. So that's going to be the area of my rectangle. All right. So on my next step, the point is moving along the curve with its x coordinate increasing at a rate of 2 units per second. So dx dt is getting bigger at 2 units per second. Find the rate of change of the area of the rectangle when x is a half. So the reason we got it all in terms of x's is because now I don't need the y coordinate really to work with anything. I can just go, okay, dA dt is, if I take the derivative of that, that's negative 24x squared dx dt. And the derivative of 8x is just 8 dx dt. And I can just plug this in directly from here, okay? All right, x is 1/2 squared. Dx dt is 2, and dx dt is 2. Okay, so it's negative 24. 1/2 squared is 1/4 times 2, and then that's 16. Let's see here. 4 goes into 24 6 times. So 6 times 2 is 12 plus 16. So for this, I get dA dt is 1028. 28. And then I don't know, the units on this, it just says units per second, but since it's area, I'm going to go units squared per second, 28. All right. So that one's a little bit more straightforward. Okay. And let's look at number 6. That is a typo. All right. And then this, you guys, is supposed to say r to the third. Pi r to the third. Some of the, anyway, some of the formats didn't keep. Okay. A spherical balloon is being inflated. Oh, I know why that 3 was there. Because it was 3 inches cubed. Okay, I gotta fix that. All right. So a spherical balloon is being inflated at a rate of 3 inches cubed per minute. Guys, that is my dV/dt. I can tell because it's cubed and it's time. So dV/dt is 3. Find the rate at which the radius is changing when the radius is equal to 5. So r is 5. So let's go ahead for part A. Let's take my volume equation. And let's take the derivative of it. So dV/dt is 4/3 pi. Now the derivative here is 3r squared dr dt. I have dV/dt. R is 5. And I need dr dt. Let me find that, like, simplify this as much as possible before I move on here. That 3 and that 3 are going to cancel out. 5 squared is 25 times 4. That's 100 pi. So I get dr dt is 3/100 pi. And for my units, I am using inches per minute. Inches per minute. All right. Okay, here is part B. Find the rate at which the radius is changing when the circumference of the sphere is 12 pi. So when the circumference is 12 pi, it wants me to find dr dt. Okay, well, we know that the formula for circumference is 2 pi r. And if that's 12 pi, then that just tells me that r is 6. So now instead of using r is 5, I'm going to use r is 6. Everything else is cool. Okay. Okay, so I can still go back, you guys, and use all this information. The only thing that's going to be different is the radius right here. All right. dV/dt is still going to be the same. Let's write this. Well, I'll just rewrite it for a sec. So it's 4/3 pi. 3r squared dr dt. So dV/dt is still 3 because that's not changing. It's the same balloon. We're just now doing it at 6 dr dt. Okay. Boom, boom. 3's cancel out. 6 squared is 36 times 4 is, I think, 144. Yeah. So dr dt at that time is 3/144 pi. All right, which reduces or whatever. You don't have to reduce it, but there you go. All right, so find the rate at which the radius is changing. Okay, find the radius at the time when, okay, so you guys, we got to attack it like this. Find the radius. So my answer should be r equals. At the time when the rate of change of the radius, okay, this is dr dt, is numerically equal. Numerically equal means it's the same number as the rate of change of the surface area, the surface area dt. So it's kind of weird. Not entirely sure what I want to do with that yet, but all right. It gave me a formula. You know what we should do with that formula? We should take the derivative. That's squared again. Sorry, let me fix this. Try to fix that on all our reviews before I pass them out. Okay. Boop. All right, so my formula is my surface area is 4 pi r squared. D surface area dt is 4 pi, and then it's 2r dr dt. Okay? Now, what it told me up here was that the surface area and dr dt are numerically equal. That and that are numerically equal. All right? So what I can actually do is I mean, I can call them both the same variable. I could call them both dr dt because they're equal. Okay, and then, as long as I'm not dividing by 0, really, I can divide both sides by dr dt. So I'm basically looking at this equation right here. I'm looking at when does 4 pi times 2r equal 1? Or when does 1 equal 8 pi r? Well, when the radius is 1 over 8 pi. Units, oh gosh, I didn't do units on this one. This one would have been inches per minute. And then the radius, when the radius is 1 over 8 pi inches, the surface area and the radius are changing at the exact same speed. Kind of weird, but okay. All right. Let's hit one more free response real quick. I feel like we did this before, but whatever. Good practice, right? 2 people are running toward a Mega Millions ticket on the ground. Person X is running toward it at a speed of 6 feet per second. So it's actually -6 though, because my triangle is getting smaller, right? Person Y is running toward it at a speed of -5 feet per second. Find the rate at which the distance is changing when X is 5. X is 5 and Y is 12. This is 5, 12, 13. Now the difference with this one is all the variables are changing. Because the 2 legs are changing, people are getting closer and closer together. So all the variables are changing, right? So when I use this equation of x squared plus y squared is z squared, they're all variables. So I got to go 2x dx dt. I got to go 2y dy dt. And then I got to go 2z dz dt. Okay? We said x was 5. Dx dt was -6. Y is 12. Dy dt is -5. Z, it's a 5, 12, 13 triangle, and we don't know dz dt. Okay? That's 60, -60. That's -120. And that's 26 dz dt. So -180 is 26 dz dt. Okay, so I can say that the rate at which they're getting closer to each other, the rate that was changing, is -180 over 26 feet per second. I suppose we could reduce that. I don't really know what that reduces to. 90 over 13. That's not fabulous, so whatever. We'll just leave it. Okay, for part B, find the rate at which the area of the triangle between the people and the money is changing. Area is 1/2 base times height. So it's dx dt times y, dy dt times x. Okay, -6 times 12, and then -5 times 5. So the area is 1/2. Oh, I'm writing area right here, you guys. This is dA dt. Sorry about that. Okay, so it's 1/2. That's -72 minus 25, which is -72 minus 25, which is -97. And if I divide that by 2, I mean, I'm just going to leave this as a fraction. -97 over 2 feet squared per second, because it's area, right? And then last but not least, we're going to do this. Now, it does not matter if I do sine, cosine, or tangent, because they're all changing. So either way, it's going to be a pain, right? So the fact that they're all changing, I'll go ahead and do sine just because the derivative of sine is cosine, and that's easy. So I'm going to say sine theta is opposite. No, I'm going to do tangent. I changed my mind. And the reason I'm going to do tangent is because I don't actually really want to work with dz dt because it's just some ugly decimal. So I'm going to do tangent instead. Okay, so tangent theta is opposite over adjacent. So the derivative of tangent is secant squared. And then I'm going to do a quotient rule right here. Derivative of the top times bottom minus top derivative of bottom over the bottom squared. Okay? So I am getting... Okay, I got to figure out what secant squared is. So I come up to this triangle. I say, okay, cosine of that angle is adjacent over hypotenuse. Secant of that angle would then be hypotenuse over adjacent. So secant squared would be 169 over 25. Fabulous. All right. d theta dt. Okay, and that's going to give me, let me get all my stuff. All right. dy dt is negative 5, x is 5. Y is 12, dx dt is negative 6 over 5 squared. Okay, that gives me negative 25 minus a negative, that'll be plus 72. Negative 25 plus 72 is 47. So that's 47 over 25. And then I am going to solve by doing the reciprocal of this. Boom, boom. And my answer for d theta dt is 47 over 169, which I do not believe reduces. Heck no. Radians per second. Okay? And there we go for our free response portion of the review. And we'll come back and look at multiple choice in just a second.